thought I'd take a break from doing the regular videos I've been doing with hive inspections and show you a little bit about how I build some boxes. I'm also going to do a mite count today, and I'll show you something I made for treating the mites with oxalic acid. So first I'm just building some new medium-sized boxes. I like to use all mediums just to keep everything standardized. Easier to move comb from one box to another if you need to. So I'm making these really simply. I start with a 1x8, just pine from Home Depot, and I rip them down to 6 5/8, which is the size of a medium box. Then I have a dado blade on my table saw, and I set the fence away from the dado to 6 inches. So I end up with a 5/8 inch shelf here, rabbit cut in the end of the board. And then I just use my biscuit joiner and some number 20 size biscuits, and they go in like this. I glue them with Type-On 3 waterproof glue, and they go together like this. Pretty simple. I don't think you need much more than biscuits to hold together these kind of boxes. Box joints are much stronger and they'll last a lot longer, but we'll see. I mean, first year, but we'll see how these hold up. You can also do splines. You could cut, if you don't have a biscuit joiner, you could cut a 1/4 inch dado in the end of the short side and a 3/8 in from the long side, or centered rather, and you can cut a 1/4 inch spline out of some wood and put it in there. I like the biscuits because when they're in there, they don't go all the way to the edge, so it's almost like a little mini tenon, so that the edge of the joinery is not like exposed to the outdoors. I don't know if it makes much of a difference though. And also you don't have to worry about up here then chiseling out your spline if you do a 1/4 inch spline. I'm kind of pretty much just following. There's a great in the Beekeepers Workshop. I don't know the URL right now, but I'll post it on the video. They've got a really good simple diagram I always go back to. There's a PDF you can download. It's got all the different sizes of the different boxes, the dimensions, and it's made for this spline method. So these dimensions won't work if you're doing like a box joint, but again, I don't see the need to do something that strong, so that's the way I do this. So I'm just throwing these together. This one, like I said, I rip them down first. I rip the boards down first on the table saw. I don't cut the boxes afterwards because I like the long strips to use for other projects. And if you cut them to length first and then rip down the boards, you're left with short things. And if you build the box first, glue it all together, then cut off the bottom, it's just waste. So I like to rip them down first. And I feel like they go together a little bit better too. This one I didn't rip down yet because I'm going to show later, maybe after this is I'm done building this, what I did. I'm going to build a simple box. I have this same size as a 10 frame langstroth because that's what I'm using. And then I am going to rip this in half. Before I do that, actually, before I assemble it, I'm going to cut a little rabbet in all the way around to kind of recess, because what I'm going to do is take this screen, just the aluminum window screen, and I'm going to staple it onto the bottom. So I have basically, this will make 2. So after I make the box, I'll cut it in half. I'll have 2 with aluminum stapled to the bottoms. And that screen is going to hold some cedar wood shavings, and this is what's called a quilt box. So there's different ways to make it, but this is what I'm going to try this year. What happens is in the winter, the bees are still making moisture, and the only thing worse than cold is cold and being wet. So there's a danger. Sometimes the moisture can condense on the roof of the hive and rain down on them. The quilt box kind of provides a little insulation, but it's meant for the air to go through the coarse wood shavings. So it'll go through these wood shavings. If it does condense, it'll condense in the top of the outer telescoping cover, and then drip down, but it won't drip on the bees, it'll just drip on the wood shavings and get the wood shavings wet. And there'll be holes at the top of the boxes, so like there'll be ventilation, so on the drier days it'll dry out, so the bees will stay nice and dry in the winter. And it does keep like some drafts from like blowing up through, so like if there's like a big gust, it'll kind of buffer that for them. So I've heard good things about it. I'm going to give it a shot this year. Kind of try to do as little maintenance as I can over the winter. Obviously, I don't want to open up the hive, but I want to kind of just get everything set early and just give them the best chance of making it through the tough New England winters. So one other thing, I'll show you. I'm going to do a mite count later today. And the way I'm going to do this is the alcohol wash method. You get a jar, like this mason jar is good because it's already got a 1/2 cup measurement on the side here. 1/2 cup is about 300 bees. So what we're going to do is we're going to take this, hopefully scoop up 300 bees up to a 1/2 cup. And we're going to sacrifice the bees. We're going to wash them in some alcohol. I'm going to dilute this a little bit. You don't need something as strong as 91% apparently, but just something to it'll kill them quickly so that it's humane. But more importantly, it's going to shake off, dislodge any mites that happen to be on them. So I'll put this cap on, give them a good shake, and then I'm going to take this cap that has a little screen in it. It's a number 8 hardware cloth. I'll put that on, and then I'm going to shake out the alcohol and the mites into this pan on some printer paper, and then I'm going to count the mites. Divide that by 3, and you got how many mites per 100 bees are in your hive. And that'll tell me if I have to treat or not. Best case scenario, I don't see any or very little mites, and don't even have to treat. There's a threshold. I have to look it up again. I don't remember. I think maybe it's like if you see 5 per 100 or something. That's a pretty bad infestation. You should treat if you see that many. The problem is that these mites they bite all the bees and they spread viruses and pathogens a lot more easily. It's one of the biggest factors of colony collapse disorder. Taking care of these varroa mites. So hopefully we don't see any today. I might make this a separate video if this one goes too long, because I also want to show you what I've made for treatment. So I decided to use oxalic acid. Until recently, like this past year, like Obama signed the Pollinators Act, blah blah blah. You push through some approval process. It's now approved for use in the U.S. Till recently it wasn't. It was only in Europe you could use it, only because it hadn't gone through the proper regulation, labeling, testing, and making sure it's safe. But it turns out it's one of the more safe treatments for the bees. It's something like, can be up to 99% effective on killing mites without harming the bees. It's one of the easier applications. It only takes a few minutes. One of the more popular methods I'm going to try is basically vaporizing the oxalic acid. You heat it up to like 315 degrees or something like that, and it melts to a liquid and then to a vapor, and it kind of like disperses in the whole hive. It's really nasty stuff, so don't get me wrong, this is not something you want to be around. You don't want to breathe it in, it's very irritating. As far as organic acids go, like citric acid's pretty safe. You can eat it, it's on Sour Patch Kids. But this stuff is another kind of organic acid, but it's not something that it would burn your tongue, it would cause you to choke, it's really bad. So we got to be really careful when we do that. And you can buy vaporizers, but I've made one that I'm going to try out myself. And Well, you know what? Let's go to the lab. I'll show you what I came up with. We'll go down in the basement. I'll show you what I've made in the lab. Okay, so here's my oxalic acid. It's you can get it cheaply as wood. It's called wood bleach in the store. It's they sell it for bleaching wood. It has other uses. There's other industrial and household uses. It's a really interesting chemical, and surprisingly, I haven't ever had any around or used it. It's also good for cleaning stuff. It's in that Beekeepers Friend, I think it's called. It's like this stainless steel cleaner that's supposedly really good. Like I said, we need to heat it up. So this is a cartridge heater. It's just 120 volt and 100 watt, and it's just a little thing that heats up. And then what I did was I made this right here. It's just a block of aluminum. It's messy because I don't have a mill, and my lathe isn't set up, and not really set up for machining right now. But it's a block of aluminum I had sitting around. So the idea is cartridge heater goes in here. It'd be hard to do with one hand, but you get the idea. Cartridge heater goes in here. There's a thermocouple that gets screwed into this hole right here, and then did a real ugly job of just kind of milling out with a drill press and an end mill, which I don't recommend. I got it done, but it's just a bad mess, bad news, not fun. Little pocket just to hold the oxalic acid. So then the heater heats up this whole block. Oxalic acid stays in this reservoir. It'll melt, it'll vaporize, and this should be thin enough to fit through the entrance and just kind of rest on the screen on the bottom of the hive and just kind of disperse the vapors. What's controlling it is this is a PID controller, proportional integral differential. It uses a mathematic formula to set an output. This is specifically a temperature controller, but PID controllers are used all over in industry and stuff. This was from eBay. You can get the same ones on Amazon. I think like $30 or so. 120 volts, and then it controls the output of this controls a solid state relay, which is inside this enclosure. That solid state relay then switches on and off an outlet here, and that'll be hooked up to the cartridge heater. So there's a little wire. This is the thermocouple lead, and the thermocouple will feed back to the PID controller, and this will set the output. It's really interesting. So I'll go into this a little bit more. We'll nerd out in this video. Basically, the way a thermostat works is if it's too cold in your house, it turns on the heat. And then it kind of overshoots, and once the heat gets to, say you set it to 70 degrees, it'll actually go to like 71, 72 or so before it shuts off, because it knows that to keep an even heat at 70 degrees with something that can only be on or off, there's no way you can set your furnace to be somewhere in the middle. It's either on or off. So sometimes you don't need it to be on 100% of the time, of course not. And if you leave it off all the time, it's going to get cold. But all you can do is switch it on and off. If there was a way to set it to, say, 20% or 50%, well, actually that's what your thermostat's kind of doing, right? So like if you look over time, over like the whole day, the whole percentage of time that your furnace is on, it might be on, say, 20% of the time. Your furnace can't cycle very often, so that's another limitation, and a lot of things are that way. This isn't. This you could turn on and off really quickly, every other minute, every minute, every second, multiple times a second. You could turn this on and off multiple times a second. And what happens is, say you're turning this on for 0.2 seconds and then off for 0.8, or even quicker, but basically averaging out to 20%. Well, you end up putting out about 20%, or like, say, 20 watts. And the way you control that is with feedback from the thermocouple that's going to be right here. So this PID controller looks at the temperature, says, I figured out, the other thing is this learns a little bit, right? So the way this, the formula inside this works is it looks over time at the temperature. So if it's 0 degrees here and you want to get to 100 degrees, it takes a note of that. It applies 100% power. As it does that, it sees, wow, this is ramping up really fast, and the formula inside this adjusts. So it knows, okay, 100% is too high. I'm going to overshoot my set point. So with this mathematical formula, it takes integrals and derivatives, basically to get the rate of temperature rise over time, and factors that in to how much power it's going to send to this. So in the end, all you have to really know is that even with the default settings here, which you can control the coefficients in this formula. So if you're good at tuning PIDs, it's a whole industry of people who get paid just to tune PIDs, so that they don't overshoot, they don't undershoot, they keep a constant temperature or regulating output or whatever it is. So even with just setting this, whatever the factory coefficients were set to, this will do a way better job at keeping a temperature steady than a thermostat. So long explanation, and there's probably a lot of like false things in there that you can call me out on if you know about PID controllers. But if you've never heard about one, that's basically what they do. They use a complicated mathematical formula to adjust an output, and they adjust the output using on-off, but like many times a second, like very fast. You can use this it works well with heaters. You wouldn't be able to use it with, say, like an air conditioner that is either on or off, and it's a motor. And there's a lot of things you can't use PID controllers for, but heaters are one that's very good. Valves, if in industry, if you want a certain water flow and you have a varying demand or supply, you can't just crack a valve at a certain point, because when something fluctuates, that's going to change the output. So PID controller is really good there. Look at the flow rate, and as it sees changes happening, depending on how fast the change is happening and how quickly it knows it can affect a change on the output, it'll actually set the valve set point continuously to adjust for the output. Really cool stuff. All it means for us is that instead of using a torch or a thermostat, we're going to be able to keep this block of aluminum really close to the exact set point that we want, which is, I got to look it up, but again, I think it's like 315, 320 degrees Fahrenheit. The temperature that this stuff vaporizes. That's about it. Here's my lab, by the way. It's very messy. A bunch of parts and random supplies and stuff, and more random stuff, and I've got some boxes here, some components, and some more under the desk here. Here's a project I haven't worked on in a while. It's a little completely built from scratch CNC engraving or milling machine. So yeah, so this is my lab. First time you've seen it, and before this, we were in the garage in the workshop, which you might have seen before in another video, but I don't spend too much time there. Usually just out by the bees. So let's get to them.